Alright, so we are going to be jumping right into Chapter 6. We just wrapped up our trig chapters, and we're just going to call it done with where we were at, and anything that you need from there that we didn't cover, we will just pick up next year in pre-calculus, assuming that you take that with me. We really didn't miss much of it. We had pretty much wrapped up the section. So that being said, we're starting in 6.1, which is evaluating nth roots and using rational exponents. So we are going to look at a couple definitions first. This will look a little different than our normal classes because of the fact that trying to kind of just speed this up and get this into 20 minutes or so of time, and then you all will just be able to look at problems, and if you have questions and stuff, you're able to message me and ask about them and such. So, starting out with some basic definitions here, we're looking at nth roots. So our first definition is for the nth root of A. And basically, all we're doing here with this is we're just going to say that this is n of A. Okay, so normally we don't write this. If n is 2, we don't write it, which would just be our square root of A, which we're familiar with. But now we're able to make this in any value. So we could have the cube root of something, we could have the 4th root of something, 5th root of something, etc. And it's of that, whatever that value A is there. And another name for that n, we say that n is the index of the radical. There. And your book gives you some examples of kind of what these powers look like and such, but we're going to look at the key concepts and exactly what that will look like for us. So, we'll start with the real nth roots of A. So real nth roots of A. So we're going to say I can draw a line. We're going to say let n be an integer, n greater than 1, and let A be a real number, then we have two columns here that we'll make. So we're going to have the first option being n is an even integer. Your other option is n is an odd integer. Alright, and within these we have three options for each one. So for this left column, we'll work our way down there. So for A less than 0, so if A is negative, there's no real nth roots. If A is equal to 0, there is one real nth root. And we would write that as the nth root of 0 is equal to 0. And for A greater than 0, there would be two real nth roots. And we've done this before with stuff, but just as a reminder that this is the case. Okay, this is equal to plus or minus the nth root of A, which is also equal to plus or minus A to the 1 over n, and we'll talk a little bit more about that notation there in a little bit. That's a 1 over n there, in case it's hard to read. So over here in the right-hand column, with n being odd, we have a is less than 0. There is one real nth root, and that would be n, the nth root of a is equal to a to the 1 over n. If a is equal to 0, we have one real nth root. So that'd be n, the nth root of 0 is still just 0, so notice those are the same for the even and the odd. And if a is greater than 0, we have one real nth root. And again, that's the nth root of a is equal to a to the 1 over n. Alright, and then we have what happens if we have rational exponents. So another chart that we will make here is, slide this up a little bit, is when we have rational exponents. So we're going to let a to the 1 over n be an nth root of a, and let m be a positive integer. I'm going to focus it real quick just to make sure that it's still good and readable for you guys. Hopefully that helped a little bit. Alright, so here we have two possibilities. We have a raised to the m over n, so a is basically being raised to a fraction. Okay, and not sure if we've really talked about this before, but the number on the top is the power that it's being raised to. The number on the bottom is the root that's being taken of it. Okay, so what this is going to look like is a to the 1 over n, all raised to the m, is equal to the nth root of a raised to the m. Okay, so that's kind of the easiest way to write it there. I'm going to focus this one more time. I can't tell if it's just the pen or the camera's not all the way focused. So, and then the next option, okay, we have is a to the minus m over n. Okay, and remember from rules of exponents that negative is going to bring it all to the bottom. Okay, so 1 over a to the m times n, or sorry, m over n, not m times n, is equal to 1 over, in parentheses, a to the 1 over n, all raised to the m, which is the same as 1 over the nth root of a, all raised to the m. And here we're going to assume that a is not equal to 0, because you can't divide by 0. Alright, so I just referred back to the rules of exponents. So keep in mind we had rules of exponents in chapter 5.1, and that was called properties of exponents. So refer back to 5.1, properties of exponents. If you need a refresher there. I'm not going to take time to write them out. You have your book and you'll be able to do that. Alright, so those are some just basic rules that you need. So what we're going to do is I'm going to work through a couple of the homework problems. You have some example problems in the book there that you can read through. I'm obviously not worried about the word problems, as you know, normally we don't really spend a lot of time with those. So you don't need to worry about those. But what we are going to work on is just going through a couple of the problems and just kind of my expectation. And the homework problems will be listed at the end of the video for you. So we're going to go ahead and switch to a new page here and get that set rolling. Alright. Alright, so 2 through 6 should be pretty self-explanatory. You may have to come back to them a little bit, but after watching this video they should make a little bit more sense. So what we're going to do is we're going to go ahead and jump down to 7 through 10. Okay, so with these ones it says to rewrite the expression using rational exponent notation. Okay, all they mean here is writing it as a fraction. Bring that down just a little bit here. Alright, so that's all they mean there. So we're just going to go ahead and we'll work through some of the even ones here, or I will, and that will allow you to kind of follow along. Alright, so we have the 5th root of 8 is this one. Okay, so remember the n is whatever number is out front here. So when we do these problems, we're taking this number here, so whatever's inside is being raised to a fraction is essentially all we're doing. So the answer to this problem would be 8 to the 1/5, because we're in technicality raising this here to the 1 and then taking the 5th root of it. So that's why it is 8 to the 1/5. Still isn't really focusing properly. I was messing around with this earlier and now it's not working completely correctly. So hopefully you guys can read this. If not, that's why I'm talking through it so you can hear it. So then number 10, it's a little harder. So number 10 is the 5th root of y plus 2 squared. Okay, so notice everything inside here is being squared. Okay, and then we're taking the 5th root of it, and that really should be down in there. I kind of wrote it out to the side a little bit too much. So when we do this, we write all this, and we're going to keep it in parentheses, so y plus 2. Now remember, it's being squared, and then we're taking the 5th root, so our fraction is going to be 2 over 5, so we're raising that whole thing to 2 over 5. Sorry guys, I really don't know what's going on with this thing right now, but hopefully it will end up focusing better for us here in a minute. Let's see if I maybe zoom it out one, if we can get it to focus in, and then go from there. That looks like it might be a little bit better, so we'll just leave it zoomed out for the time being and go from there. I think it'll make it a little easier for you to read. So, and if there's any questions about anything I'm doing, feel free to email me or use the Google phone number that I have set up as well. Well, that will be an option. Alright, so that's that section. So the next thing is to rewrite the expression using radical notation. Okay, so this is essentially the opposite. Okay, so this section up here and this section down here are pretty much just the opposites of each other. So in this one you'll be given a number raised to a fraction, and then you'll need to take the root of it. And if there's anything that's being raised to a power, you'll need to do that as well. So, we're looking at number 12, 7 to the 1/3. Well, 7 just goes in the radical, it's being raised to the first power, and it's being the cube root taken of it, so it'll be the cube root of 7 for that one. Let's see, number 14, we have x raised to the 7/6. So in this case, okay, we have x being raised to the 7th, okay, and then we have it being the 6th root of that. So I'm going to show you two ways you can write it, and either way is fine. Okay, the book's going to write it this way, so we have the 6th root of x raised to the 7th. So they put that x to the 7th all inside. Now, I'm okay with you also writing it this way, the 6th root of x all raised to the 7th. Okay, I would say probably stick to this form here, this first way I wrote it like the book does, but there's absolutely nothing wrong with this second option here. Alright, so with the next section we are finding the indicated real nth roots. Okay, and that could just be one or none of A. Okay, so this will be following those rules that we wrote down. So with 16, we are told that n is equal to 3 and A is equal to minus 27. Alright, so looking back to our rules here, n is odd, so we're going to be looking at that right-hand column that we wrote down. Okay, and A is less than 0. Okay, so according to our chart, so look back to your chart that you had, that tells us that we're going to have one real nth root. Okay, so the way we're going to write that is we're going to write it as the cube root of minus 27. Okay, so that's the way we can write it and the way we're going to think about it. Now, in here, in terms of how we're going to write our answer, is it actually wants to know what those roots are. So the cube root of 27, okay, and it's going to be negative because we're dealing with odd powers here. Okay, remember, if this was an even power, we could not have a negative in here. Okay, but this is an odd power, so we can. So the cube root of 27 is 3, because 3 times 3 is 9, times 3 is 27. So this is going to be 3, but remember, because of this negative sign, we have to write the negative out here. So our answer would be negative 3 in this case. For number 18, n is equal to 3, and A is equal to 343. Okay, so this one's pretty similar here. So n is 3, so we're taking the cube root of 343. And if you wanted to write it as 343 raised to the 1/3 to set it up, that's fine too. Either way, typically I'll write it in this radical form, but either way is fine. So the cube root of 343, you may not know that one off the top of your head, which is fine, but it is 7. And my book is falling. Let's see. 20 kind of follows the same pattern, so we won't look at that one. Evaluate the expression without using a calculator. Obviously, I can't see if you're using a calculator, but the expectation would be that you would be able to do these without one. So I'm going to evaluate without a calculator. So with these ones, start with something like 22. We'll just work our way down accordingly. We have 8 to the 1/3, okay, which I can think of as the cube root of 8. Well, what's the cube root of 8? Well, 2 times 2 is 4, times 2 is 8, so it must be 2. Let's see. 24 is the cube root of minus 125. So that one, obviously, we could think about as minus 125, all raised to the 1/3 if we wanted to, so just purely notation here. So the cube root of 125, well, 5 times 5 is 25, times 5 is 125, so it's going to be 5, and because it's negative here, we're going to have that negative out front. Let's see, let's jump a little bit, do 28. So 28 is the cube root of minus 64, all raised to the 4th. And I know I did say that we're probably going to be about 20 minutes. This one's probably going to be about 3 to 5 more minutes, just in case you are following in time and thinking that we should be almost done. Alright, so we have negative 64 here, and we're taking the cube root of it, and we're raising it all to the 4th power. Okay, so my fraction is going to be 4 over 3. Okay, so I have that negative 64 here. We have the cube root, and we have it raised to the 4th. So there's a couple ways we could think about this problem. So this is one that I'm more inclined to here personally to rewrite as negative 64 raised to the 4 over 3. And now remember that negative sign goes inside. So when you get a problem like this, you have a couple options. You can either go ahead and raise it to the 4th power and then take the cube root of that, which typically is going to be a lot harder when you have a bigger number here. Okay, or your other option would be to take the cube root first and then raise it to the 4th power. So I would say take the cube root first. Okay, and with that we have to think about, okay, what are we looking at here? So we know 8 times 8 is 64, so obviously that's too big to give me the cube root of it, but maybe 4. So 4 times 4 is 16, times 4 is 64. So that tells me that the cube root of it, when I just take the cube root, I'm left with negative 4. Okay, keep in mind the negative because we took the cube root. So negative 4 all raised to the 4th now is what we're left with. Okay, and then with this, we now need to raise 4 to the 4th. Well, we just said that 4 times 4 is 16, times 4 is 64. So times another 4. You may not know this one off the top of your head, but it'd be really easy to do just as a quick little scratch work on paper. It's 256. Okay, and because we're raising it to the 4th, that negative goes away, so our answer is positive. Let's see, we'll do one last one of this type, and then I will demonstrate it really quick on the calculator as well. Number 32, okay, we have 1 over 81 raised to the minus 3 over 4. So remember, if we have a negative exponent, that takes the whole thing and moves it up to the top. Okay, if it had been on the top, and move the whole thing to the bottom. So we can rewrite this as 81 to the 3 over 4. And again, I like to go ahead and do my roots first, probably 9 times out of 10. So the 4th root of 81, well, I know 81 is 9 times 9. So that's an easy way to think about it. And I know that 9 is 3 times 3. So the 4th root of 81 would be 3. Okay, so this is a lot of just thinking about your math and thinking about things that you know to help you figure it out. So I'm left with 3, and I still have to raise it to the 3. So 3 times 3 is 9, times another 3 is 27, and so my answer would be 27 here for this type. Alright, let me grab my calculator real quick, and I'm just going to do one little demonstration. Hopefully you'll be able to see it as to how to plug it into your calculator for problems like 34 through 45. Alright, so I'm going to grab a new piece of paper. Hopefully you've had time to jot all of that down. And we're wrapping up here, I promise. Alright, so we are now using a calculator, and we're rounding to 2 decimal places. Evaluate with a calculator. Round to 2 decimal places. Okay, so I'm going to show you how to type these into your calculator, or your 2 options for typing them in, and hopefully that will help you out a little bit. Alright, so something like 34. Okay, and I'm only going to do a couple of these for the sake of time, but it all follows the same pattern. So the 5th root of 32,768. You're probably thinking, wow, I really don't know how to do that. I'm going to focus this here before I put my calculator under it, so hopefully you'll be able to read it, and I'll definitely be talking through it to kind of help out here. Alright, so I have my calculator on. Hopefully it's readable. I don't know if maybe some of it is the lighting here, so I'm doing a little bit of trial and error here. Dim the light and see if we can get it in focus. looks a little better, I think. So, with our calculator, okay, you have a couple options. So normally when we're doing this, our square root button is right here above our x squared. But we don't just need the square root. We need the fifth root, so we don't use that button. Okay, we're going to hit second, and then the math button. Sorry, I always say the wrong thing. Just hit the math button. There we go. Alright, now, I know there's a glare on it, but if you look down here, okay, we have a couple options. So if you're taking the cube root of something, you would hit the number 4. Okay, but we are taking the fifth root, so we need this one. That's number 5, so it's the x root, basically, of, and then it has a little radical there. So I just hit the number 5 on my calculator. It's the easiest way to bring it up. Okay, now, there was an answer stored in my calculator, so I have to go over here and clear this out to get it to work, but I can just replace that with a 5 because I'm taking the fifth root of the number, 32,768, and I take the fifth root of that is 8. Alright, so the answer for that one is just 8. Okay, and we'll do one more of that type just so you can see it. So we have the ninth root of minus 230. So here, again, we hit the math button. The number 5 is what brings up the one we want. Now notice again, it pulled in my answer, so I'm going to go replace that with 9 because I need the ninth root. I'm going to put in that negative, so negative 230. Enter. Now notice the number is negative and it's a decimal, so we're going to round it to 2 decimal places. So the answer is minus 1.8. Now notice that 9 is there, so that now 9 is going to round that 2 up to a 3. So I'm at minus 1.83 for that one. Alright, and then the last thing that I'm going to show you here, actually I need to do 2 more. So we're going to do number 40. Is the fourth root of 187 and all of that cubed. Okay, so this is going to be where it's really important that you keep up with your parentheses and stuff. So I'm going to start with a parentheses, okay, and I'm going to hit math, the number 5 to bring up the root that I want, and I'm going to do the fourth root of 187, okay, oops, I just accidentally cleared that. So let me do that again. So parentheses, and then the fourth root of 187. Alright, I'm going to close my parentheses, and I'm raising the whole thing, because remember, use the caret button here, raises it to the third. Alright, and that gives me 50.5686, and so on. So when I write my answer, okay, I'm going to write my answer here as 50.5. Now the 8 moves the 6, rounds the 6 up, so 0.57 there, so 50.57. Trying to write beside my calculator is causing a problem. Alright, and then the very last thing here that we will do, trying to give you guys plenty of examples, is number 44, 1,974, all raised to the 2 sevenths. Okay, so now you could rewrite it and type it in your calculator like we did this one, okay, but the way I would actually recommend to do it is to type in the number 1974 and then raise it all to 2 divided by 7. So notice it actually will do it for you, okay, so 2 over 7, and then hit enter, and that gives us 8.74, and that would be our answer for that one. Okay, so that's all that you're going to be required out of this section to be able to do. So let me give you guys some problems here to go along with it. Okay, we're going to say 3 through 45 odd. Okay, these problems should be relatively quick, so they shouldn't take you much time to do. Sorry this video did go a little longer than I wanted, but I wanted to make sure you guys had plenty of examples. hopefully the future ones won't be quite so long, but like I said, I did want to make sure you guys had enough to be able to do this stuff.